Hello students. In this class we will discuss about some problems regarding the slip and speed of the three-phase induction motor. In that first problem, first read the problem. The problem is a three-phase four-pole 50H induction motor having a slip 0.04. First question, speed of the induction motor. Second question, rotor frequency. Third question, rotor speed with respect to rotating field. First, we will write down the given data. First is a three-phase system. We know that number of poles is mentioned, that is 4 poles, and the frequency is 50 Hz. And he is given the slip value is 0.04. The first question is speed of the induction motor. What is the formula for speed of the induction motor? Any speed of the induction motor is like this: ns into 1 minus s. Nr is speed of the induction motor, ns is the synchronous speed, s value is the slip. But we don't know the synchronous speed value. So then we will find out what is the formula of the synchronous speed. Ns equal to 120 F by P is the formula. From that, this is the 120. Is given the frequency is 50 Hz and number of poles is 4. Then 4 3 times cancelled. 3 into 50 we will get the 1500 rpm. So ns is 1500 rpm we got. Now we will find out the first point. The first point is rotor speed. Rotor speed equal to ns is 1500 and into 1 minus s. 1 minus s means 0.04. Therefore 1500 into 0.96. So by doing that we will get 1500 into 0.96 is 1500 into 0.96. We will get 1440 rpm. The value is the 1440 rpm. So then the induction motor rotates with the speed of 1440 rpm. Next, second point. The second point is rotor frequency. What is the formula for rotor frequency? Rotor frequency is nothing but slip times of stator frequency. Slip times of stator frequency. What is stator frequency? Stator frequency is nothing but supply frequency, because we are giving supply to the stator only. This, what is the stator frequency is 50 Hz. So this is the AC. So that's why you have to write what is the slip value. Slip value is given 0.04 and stator frequency is 50. Then what is rotor frequency? So rotor frequency equal to 0.04 into 50. We will get 2 Hz. 2 units are hertz. Whenever the stator frequency is 50 Hz, if you look at here, then the rotor frequency is 2 Hz. Compare with the stator frequency, rotor frequency at running condition very less. Very less. What is the reason? The reason is the rotor frequency is nothing but slip times of the stator frequency. Slip is always less value, that's why it is low value. Next, third point. What is third point? Rotor speed with respect to rotor field. So you know that rotating field with respect to rotating field. So in the field, it is a stator, it is a rotor. For example, it is a stator and it is a rotor. So whenever we are giving the supply, stator magnetic field is always rotating ns, rotating field having the speed of synchronous speed. Look at here. Yes. But what is the rotor speed here? Rotor speed is, we are getting the rotor speed value is nr equal to 1440 rpm. 1440 rpm. The question is rotor speed with respect to rotating field. Rotor speed with respect to rotating field. So with respect to rotating field means rotating field speed is rotating field speed equal to, it is a synchronous speed, that value is 1500 rpm, and the rotor speed is 1440 rpm, right? Rotor speed with respect to rotating field. Then in order to get the third point we have to do the multiplication, but on multiplication is rotor speed with respect to rotating field. So then nr minus ns, nr equal to is nothing but 1440 rpm minus what is synchronous speed? Synchronous speed is 1500. Then you will get minus 60 rpm. Minus 60 rpm. The rotor speed with respect to rotating field is minus 60 rpm because it is less compared with that speed. Okay. So this is the procedure to do any problem like this model. First, if you ask to find out the speed of the induction motor, first you have to find out the slip. Look at here. First, if the slip is given, directly you can use this formula. If the slip is given, you have to use this formula. If the slip is not given, then it is somewhat, then you have to find out the slip. This is the model. And this is also one of the important model, that is he will ask the rotor speed with respect to stator field or stator or rotor field, like that. Then you have to compare with the both the speeds, then you will understand. Next, the second problem. A three-phase two-pole 50H induction motor has full load speed 2850 rpm. For this, calculate first point is slip and second point is speed of the stator field with respect to the rotor structure and stator structure. Okay, first write down the given data. For that, a three-phase system, number of poles are 2, frequency is 50 Hz, is given the speed equal to 2850 rpm. First point is asking to find out the slip. So what is the formula for the slip? Slip formula is ns minus nr by ns is the slip. And so here we know the nr value. Nr is nothing but speed of the induction motor, but we don't know the ns value. So what is the formula for ns? Ns equal to simple 120 f by p. 120 f by p. Here we have 120. Frequency is 50 Hz. Number of poles are 2. Just write down the poles. Then 260 times 6 5 are 3000 rpm. This is about the 3000 rpm. Therefore, from that we can find out the slip value. Slip value equal to 3000 minus rotor speed equal to 2850 by 3000. Then by doing this we will get 3000 minus 2850 divided by 3000 again. So we will get the slip value is 0.05. Then the first question is find out the slip. The first question is completed. Next, what about second question? Is asking to find out the second question. Stator speed of the stator field. First, what is the stator field speed? Generally, stator field or rotor field, nothing but rotating magnetic field. Stator field speed equal to synchronous speed, that is ns. Generally, this is the 3000 rpm. First question. with respect to rotor structure. What is rotor speed? Rotor speed is nothing but induction motor speed. What is rotor speed? I already mentioned 2850 rpm. The first question is speed of the stator field with respect to rotor structure. Rotor structure means the first question is we can write stator field is asking to find out stator field with respect to ns minus n. The first question, what is ns? Is 3000 then the first answer is 150 rpm. The first question is speed of the stator field with respect to rotor structure is 150 rpm. This is the 150 rpm, right? Next, second, speed of the stator field with respect to stator structure. Look at here, stator field, stator speed. What is the stator speed? Stator is always constant. Stator field speed is always constant, that is always zero, it is stationary. But stator field is always synchronous speed. So therefore the second question is, that is speed of the stator field with respect to stator structure is ns minus 0, that equal to ns. Ns means, what is ns? What is synchronous speed? Synchronous speed here is 3000 rpm. 3000 rpm. Then the answer is speed of the stator field with respect to the rotor structure is the 3000 rpm. Why? Stator is always stationary, but stator field is always rotates with synchronous speed. The synchronous speed is like this. Okay, this is about the second question. Next, we will look into the third question. Next, third question. Third question is a three-phase six-pole induction motor running at 976 rpm. At standstill condition, rotor parameters are R2 not equal to ohms, X2 not equal to 0.3 ohms. Find out rotor parameters during running condition. This is the question. So simple. First, write down the given data. A three-phase six-pole induction motor. So number of poles are given is 6 poles, and the rotor running at the 976 rpm. At standstill condition, rotor parameters. At standstill, what is the meaning of standstill? At standstill condition means rotor is stationary. That means rotor doesn't rotate. Rotor speed is 0. We can take it as rotor speed is 0 simply, right? So in that condition he mentioned two things. One is rotor resistance. R2 means at standstill condition, 2 means rotor parameter, R means resistance. Okay, R2 not equal, he's mentioned 2 ohm. Second, X2 not, rotor reactance equal to 0.3 ohm. Find out rotor parameters during running condition. The question is, he is asking to find out the running condition. At running condition, what are the changes in parameters? Okay, so first running condition rotor parameter, we can take it as R2, and R2 and R2 not both are same, there is no change. For rotor, the resistance is not changed while it is running or while it is standstill. There is no change in rotor resistance. That's why R2 equal R2 not, it is 2 ohms only. Then what about reactance? At running condition, reactance can take it as X2, that is S times of X2 naught. S times of X2 naught, but we don't know the X value. Now we will find out the slip value. What is the formula for the slip? Ns minus Nr by Ns is the slip. And what is Ns? First you have to find out the Ns. Ns equal to 120 F by P. This is 120. What is F? Is 50. What is P? Number of poles are 6 poles. So 6. Number of poles are 6. 620 times 20 into 50 will become 1000. Now we will find out the slip value. Slip value is 1976 by 1000. By doing this, 24 by 1000. Finally, we will get slip value equal to 0.024. 0.024. Then you will substitute this slip value in the rotor reactance. X2 equal to S value 0.024. What is X2 naught value? X2 naught value equal to 0.3. Then we will get 0.024 into 0.3. 0.024 into 0.3. Then X2 value is 0.0072 is the ohms. This is the procedure to do the X2. So always you have to mind it. Rotor running condition is different from the rotor standstill condition. Whenever a rotor condition we have, then automatically we have to analyze all these things. All these things. So this is the some problems regarding the speed of the induction motor. Okay, thank you.